Hi everyone, so today we're going to talk about graphs, how to read graphs, how to set up graphs, and some key components that you're going to need when creating or really reading any graph that we see. So to start off here, we're going to talk about some components. So we have a y-axis and an x-axis. So if I were to draw that out, here's my graph, here's our x-axis, here is our y-axis. And it's important to note that the x-axis is always going to be our independent variable. And we also want to make sure that we label all of our axes with units and what we're looking at here. Same thing with our y, except here we have our dependent variable. And again, we must have it labeled with units. Next important component here is our title. So title should always include the independent and the dependent variable. And it's really just describing what we're seeing on our graph here. So since we are looking at independent and dependent variables, you want to make sure that somewhere in there it's explaining what we're looking at here. And we'll give some examples in just a minute. And then the last thing is something called a key. So a key has to be included if there are multiple trials indicated in a experiment. And again, we're going to see examples of all these different types of things in just a minute here. There's also two different types of graphs that we're going to see. And those are going to be line graphs and bar graphs. And I'm going to talk about when we should use each of those. So let's take a look at our first one. We can see that we have a graph here. Here is our x-axis, here is our y. We have it labeled, we have temperature and enzyme activity. So this is a very, very basic graph, and if you've noticed, we're missing a few things here. A title and things like that. So if we take a look and think about, we're talking about temperature and enzyme activity. So if we were to make up a title for this graph, it might be something like the effect of temperature on enzyme activity. So we know from our graph that we saw that our independent variable was temperature and our dependent variable was enzyme activity. So we have that right here. And then if we were to make a claim about our graph that we just saw, let's go back to our graph. We can see, look, as temperature increases, say we're increasing this way, we're also going to see that enzyme activity is increasing as well. So as temperature increases, enzyme activity increases until it reaches optimum temperature A, and then it will decrease. So that is a claim that we can make about that graph. Not too many numbers on this graph, as you'll notice, but that's a really great claim, and we can see the evidence there is right where we see it. So here's our next graph. So take a look. We're going to see temperature again, enzyme activity. Notice we are again missing a title, but we're still talking about temperature and enzyme activity. So you're going to see how these graphs are compared. So something you do notice here is that we have numbers on the bottom, and they're all going up in even increments. So we go 0, 10, 20, 30, 40, 50, 60, 70. We can see that there's an optimum temperature line here. So this is where that enzyme is going to work the best. So let's break down this graph a little bit. So again, the title here could be the effect of temperature on enzyme activity. So again, we can see our independent and dependent variable here. So temperature is our independent, and enzyme activity is our dependent. And then there's a couple of claims that we can make according to this graph. So enzyme activity increases slowly from 0 to 20 degrees Celsius. Another claim we could make, it increases more rapidly from 20 to 40 degrees Celsius. Another claim we could make is that temperature peaks at 40 degrees Celsius. And again, we can see again a claim we can make is enzyme activity begins to decrease from 40 to 60 degrees Celsius. So again, all good claims, all claims that can be supported by the graph as evidence. So a lot more going on here, and I want you to notice something. We have a key. So there are multiple trials in our experiment here. So we can see that we have day plant was measured in our height. And then we can see all these different trials. So we have another trial here, 1 hour of sunlight, 3 hours of sunlight, 6 and 9. So as we see here, we can take a look. Again, no title, but let's make one. So the effect of sunlight on plant growth. Our independent variable here is going to be sunlight. So the reason it's not day measured, though time is another important thing, is because we have all these trials here. So these trials are going to tell us what we're changing. So we can see the graph changes depending on the sunlight. So that's our independent variable. Our dependent variable is going to be plant growth. That was on our y-axis. Our key is representing the different trials performed in the experiment. And a claim we can make here, plants that receive more sunlight will be taller. So we saw that with our graph. Here's our 9 hour, this is our 9 hour line. We can see overall that plant is taller than any of our other plants here. Okay? Last graph that we're going to talk about here, this is a bar graph. So I want you to notice something about our line graphs and our bar graphs. So our line graphs, we're looking at things over a period of time or sequentially. So we could place all of those in some sort of sequence. Where our bar graph here, there's really no sequence. So let's take a look at what we're talking about. We're talking about brands of fertilizer. So there's no sequence that we can put brands of fertilizer in. So that's why a bar graph is really good to use, because we're comparing different objects here. So bar graphs are more for comparing of different objects and things like that, where line graphs are used for sequential measurements. So again, we can take a good look at this graph. We're talking about brands of fertilizer and then height in centimeters of our plants. So a good title here would be the effect of different fertilizers on plant growth. Again, talking about the independent variable and the dependent variable. So again, brands of fertilizer is that independent, dependent is that plant growth. And there are quite a few claims that we can make here. So the first one is that the granny bloomers can cause plants to grow almost 20 centimeters more than the control. Kmart fertilizer caused plants to grow double of what the control was. Job's worked about as well as the control. And Miracle-Gro resulted in plants half as big as the control. So again, all of these different claims are supported in our graph, and we would be able to take those numbers from this graph as evidence. So if you have any questions here, please let me know, and we'll be doing some practice with these.